All right, today we're going to take a look at doing the graphs of sine and cosine functions. So doing those curves. So we're away from the triangle, so you do get a little bit of a break here today. Now I am going to spend a little bit of time talking about sine and cosine, because sine and cosine, remember, are related to secant and cosecant. So if we are proficient at sine and cosine, we're going to make your life super easy then for secant and cosecant. There won't be a lot of additional work to do when we get to those graphs. All right, ignore the bell ringing over here at school. Let's get into it. So properties of sine and cosine. So of course we need to talk about some different things and how to represent these graphs. So clearly, of course, just take note, A is your lead coefficient on both function, and then B is the coefficient on x, the number in front of x. So just take a look at those as we go through and do these definitions. So periodic. These are curves that are going to be repeating on the graph. Now, how do we figure out how often they repeat? The full period, of course, is 2 pi, and then we're going to divide by the coefficient on x. That's how often it's going to repeat. We also want to know the amplitude. How high are the curves going to be? So absolute value of your lead coefficient, of A. So that's how we're going to figure out the height of the curves. Now, the other pieces of the puzzle that's going to help me draw these graphs, they're incremental. So the 4 key points in one period. So we're going to take our period, that 2 pi over b, whatever we got, and divide it by 4. Now, the other thing we're going to see, of course, reflections. If your lead coefficient is negative, it's going to reflect over the x-axis, so it's going to flip, so to speak, and we'll see that when we also draw some of the graphs here coming up. And the phase shifts. Now the phase shifts we're not going to actually get into the drawing of today. That's going to be the B part of the lesson, but I put it in here on your notes so that way you have everything in one nice place. So phase shift, that's moving your graph left or right. We know this from all those transformations you covered in Algebra 2. If you are adding or subtracting something to x, in this case they're using c, that's going to move your graph, of course, left or right. How to figure out left or right, which direction and how much, you're going to do c divided by b. So again, for today, we're not going to graph the phase shifts. We're just going to put this in our notes so we have everything in one nice place. So just get everything jotted down. So baby steps. First thing we're going to do before we even draw any of the graphs is just figure out the period and the amplitude. We're going to work our way up to the graphs. So period, remember, let's start with that. Period is 2 pi over b, and our b is the coefficient on x. Clearly, I'm just going to simplify that down. So what does that mean when we actually draw the graph? From 0 to 1 pi will look the exact same as 1 pi to 2 pi. That will look the exact same 2 pi to 3 pi, so on and so forth. Okay, amplitude, of course, absolute value of A. Just do that in your head. And of course, that's how tall the curves are going to be. All right, so let's practice on this one. Period, of course, 2 pi over b. Now, the coefficient on x this time is 1/2. So yes, you have to do a little bit of fraction work on this one. 2 divided by 1/2, 4. So again, what does that mean? Your curves are going to look the same from 0 to 4 pi, 4 pi to 8 pi, 8 pi to 12 pi. Those will all be looking the same. Amplitude, of course, absolute value of A, our lead coefficient, which just 3/2, 1.5. There is a little bit of fraction work in some of these graphs, just to warn you. Okay, period, 2 pi over b. Now, don't let it scare you. Our coefficient on x is pi. Remember, pi is just a number, so it's okay if you just end up with a period of 2. 0 to 2 will look the same, 2 to 4, 4 to 6, so on and so forth. Amplitude, absolute value of A. So this one would be a short one. 1/2 is going to be pretty tiny to draw. We got to actually draw the graph. All right, period, 2 pi over b. b on this case, our coefficient of x is just 1. That's nice and easy to calculate. Amplitude, absolute value of A. So our height is 2. The negative would just be a reflection over the x-axis. And you'll see that when we get into the actual drawing. Again, all right, ignore the bells. I shouldn't record these before school. Okay, period. 2 pi over b. b, of course, our coefficient on x. And I'm going to reduce this down. Why are we practicing this so much? Because if we can get the period and amplitude, there's no way we're going to get these graphs correct. And of course, the negative is just going to be your reflection. All right, let's do x. So, period, 2 pi over b. Now this time our coefficient on x is 2/3. So just to review your fraction work, when you divide by a fraction, you multiply by the reciprocal. So the 2's are going to cancel out, so 3 pi. So 0 to 3 pi looks the same as 3 to 6 pi. That looks the same, 6 to 9 pi, so on and so forth. Amplitude, absolute value of the lead coefficient. So this would be a little tiny short one. Okay, so just practicing our period and amplitude so we can get ready to draw our graphs. Let's take a look at this. So we're just going to talk about the relationship. I think that was the last vowel. So the relationship between f and g. Clearly g, they had added this plus pi on. So if you remember, of course, all those transformations from Algebra 2, that is a horizontal shift. It's going to move it left or right. And of course, how to find that, you're going to take whatever they're adding or subtracting to x and do the opposite of it. So since it says plus pi, negative pi. And it's over the coefficient over b. Now, since it's negative, it's going to move it negative pi, of course, to the left. So that would just shift your whole entire graph to the left when we get to drawing those. Again, we'll be drawing those in the B part of the lesson, just practicing today. Okay, from F to G on letter B, I see they put the negative on front of it. So of course the negative is always a reflection. And if the negative's on the coefficient of x, it reflects over the y-axis. So we have to specify which axis we are reflecting over. If the negative was in the front, I'm going to draw it, but I'm going to quickly erase it. If the negative would have been in the front of the sign right there, that black negative, that would reflect over x. Take that off really quick so we don't throw you off. Okay, so let's take a look at C. So clearly the difference is we have this minus 2. So they're not subtracting 2 to x, so that is a vertical shift. So it's going to be up or down. Since it's negative, it's going to shift your graph 2 down. And let's take a look at D. We've got a negative now on the front and the half. Well, let's talk about the negative first. That's always a reflection. This time it's in the front, so it reflects over the x-axis. And the half. So we went from one sign to a half sign. So that is going to shrink your graph. It's going to be half as tall. So I'm just going to say vertical shrink. So it's nice to just kind of recognize what's happening between the graphs before we get into actually drawing them. All right, let's draw them. Sketch the graph of the following. So, plain basic sine curve. So things, of course, we want to know. Amplitude, how high it is. I want the period. So just like we did in that first example. Now, I also want the increments. That's going to help me draw also today. So amplitude, absolute value of A. Period, 2 pi over b, our coefficient on x is 1. Now, what's important about the increments is that's how I'm going to scale the graph grid. So increments is the period divided by 4. And I'm going to reduce that down. Okay, clearly not drawn to scale. We all know my artistic abilities. So first thing I'm going to do, just put on my x and y axis, of course. My amplitude is 1, so I'm going to mark 1 up, 1 down. And then I'm going to scale the x-axis by half pi, by the increments. So I'm going to start here, half pi. Now I'm going to try to make them even, but again, we're freehanding this. We're just going to do the best we can. A little more than 0 to half pi, but we're going to go with it. Half plus a half, 1 plus another half, 1 and a half. I just put it in proper, just fits a little nicer. 1 and a half plus 1 more half. Okay. So when you draw your sine curve, which is what I'm going to draw. That's going to be one period of my sine curve. Sine always starts at the center line. So I'm going to put a little note here. Now, for us, there are center lines at 0, 0. But in the B part, we're going to be moving the graphs up and down. We'll have the vertical shifts. So that's why I got fancy and said center line. For our cases, it's starting at the origin. Now, our lead coefficient, +1, so there's no reflection. And again, when I draw, I'm like, oh gosh, is there a reflection or not? No, +1, so I want to go up to 1 next. Back to the center line. Down 1, center line. Now, we will always ask you to graph 2 full periods. I have 1 period on there. So I could extend to the right and go out from 2 to pi. I might run out of room. Or I'm going to go to the left and I'm going to subtract half a pi. Subtract half a pi. Subtract another half. And subtract another half. And it doesn't matter to me which way you do it. Sometimes I will extend out to 4 pi. It sometimes mostly depends on space. So I'm going to draw the exact same green curve on the left side of my graph. There it is. Got it. So that's 2 full periods of sine, and you will be asked to always draw 2 periods of it. Now, cosine, similar. I'm going to do the amplitude, the period, the increments, all the exact same. The only difference is when I draw cosine, it's going to start at the amplitude. The starting point changes. So let's do a basic cosine graph. So same thing, amplitude, absolute value of your lead coefficient. So it's the same height, period. 2 pi over b, the coefficient on x. Increments are going to turn out to be the same, period divided by 4. So everything right now that I've written down is exact same on sine. The difference will be when we draw the curve. So I'm trying to scale this similar to the last graph, of course. I'm going to go up 1 for the height, down 1. I'm going to count again by half pi, half plus a half, 1 plus a half, 1 and a half, plus 1 more half. Okay, cosine. Let's put a little note over here. So cosine does not start at the center line. Clearly that would be sine. Cosine starts at A, your lead coefficient. So I see my lead coefficient's positive 1, so cosine's going to start right here. And I'm just going to put a little note. That's why I'm starting, just so you know. Now that's your maximum height. I can't go any higher than that. So now I'm back to the center line, down 1, lowest I can go, back to the center line, up to 1. Got it. Now I could continue on my graph out to 4 pi to the right if I wanted my second period to go to the right. Clearly I might run out of room, maybe not, but I'm going to do it to the left just to keep it balanced like the last one. So I'm going to subtract half a pi now. And I'm going to draw that exact same blue curve. I'm just going to take it and repeat it over here. Got it. So I'm going to start labeling, of course, my starting points just so it's obvious for you, especially when we're moving the graphs up, down, left, and right. I don't expect you to label it on the graph where, the start point is. I'm just doing that for your benefit. All right, let's change it up here a little bit. Let's change the amplitudes, of course, and let's change up some of the periods. So amplitude, absolute value of A, the lead coefficient. So it's going to be twice as high as the previous graphs. Now I am going to try to scale it accordingly and make it twice as high, but again, we're freehanding these, so no promises. Period. 2 pi over b. So this time just 1 pi. Now we need the increments. Period divided by 4. Okay, so let's get this drawn. And again, I'm going to try to draw it accurate. No promises on my artistic skills. So this time, of course, our height is 2. So I'm trying to make it twice as high as the last ones. No promises. This time we're incrementing our graph by 1/4 pi versus half. So it is a horizontal shrink. It should be less wide than the previous graphs. Now I'm not going to guarantee it's going to be exactly, half as wide, but I'm going to 1/4 plus 1/4, half plus 1/4, 3/4 plus 1/4. So you can see I've got it kind of squished together. That's intentional. Now, the cosine curve, cosine starts at the A, at the amplitude. So here's my starting point. I'm going to be back down to the center line, down 2 more units, center line, up. So you can see, I hope from the previous graph, that we have a vertical stretch, it's twice as high, and a horizontal shrink. It's more narrow on the x-axis. Now, it's up to you if you want to go to the left. This time, just to show you, I'm going to do my second period out to the right. So I need 4 more increments. I'm going to keep scaling by 1/4 pi. I left off at 1. So 1 plus 1/4 would be 1 1/4. I'm just going to make it improper so it fits in there a little better. 5 pi over 4. 1 1/4 plus 1/4, 1 1/2. 1 1/2 plus 1/4, 1 3/4. 1 3/4 plus another 1/4. Okay, and I'm just going to continue on with my blue curve. I'm at my max height of 2, so back to the center line, down 2, center line, up 2. So I'm going to have that exact same repeated blue curve. Got it. You could have subtracted to the left. It doesn't matter to me, just as long as you have 2 full periods. All right, let's take a look at D. So sine curve, but everything starts the same. Amplitude, period, increments. Amplitude, of course, absolute value of A. So this is going to be the same height as the last graph. Period, 2 pi over B. And increments, of course, 2 pi over 4. So no horizontal shrink. It's going to look like that original sine curve. I'm just going to stretch the height of it to 2. I'm going to try to. No promises on how accurate we can make it. But we're going to try. Always try. So amplitude 2, down 2. Okay, so this one I'm not going to shrink it on the x-axis. I'm going to try to keep it similarly scaled as the first graphs. Half plus a half, 1 plus a half, 1 1/2 plus a half. All right, there's my fraction work. Now, sine, remember, starts at the center line. In our case, on the origin. I'm just going to pull a note, that's where I'm starting. Now, this time, we technically have a reflection. Or really, I don't get carried away with that when I draw it. I just see the -2, and I know I'm going to go down 2, back to the center line, up to center line. So when you have that negative on your lead coefficient, you should have a valley and then a hill. That's how I think the sine. Now, I'm going to do my second period to the left. I'm going to subtract. So I'm going to do negative pi over 2, subtract another half, subtract another half, and one more. That's a sloppy 2 pi at the end there. So same thing. I'm going to repeat that same green curve. So I want my valley and then the hill. Got it. All right. Ooh, that's a little rough there in the middle, but we all know my lack of artistic skills. Do the best you can, right? No judgment. So same thing. Amplitude. Period. Now, we're doing a lot of these sine and cosine curves because remember, like I said, if you're good at these, we're going to make your secant and cosecants easy. So amplitude, absolute value of A, period, 2 pi over B. This time our coefficient on x is a third. So 2 divided by a third, 6. Increments, our period, divided by 4. I'm going to reduce that down. So every 1 1/2 pi. So we're stretching out our x-axis. So I'm going to draw pretty wide. I'm going to try here. X-axis. I'm going to try to draw them to scale. Okay, amplitude 1. Now, this time we're scaling by 1 1/2. So if I look at my previous graph, I don't know if I can do 0 to 1 1/2 all the way through, but I'm going to try to widen it. So I'm going to kind of 1 1/2 pi. 1 1/2 plus 1 1/2. 3 plus 1 1/2. 4 1/2. 4 1/2 plus 1 1/2. Got it. So I'm stretching it out on purpose. Now, sine, of course, starts at the center line. Positive 1 for your lead coefficient, so up to 1. So you can see I've stretched these curves out. Positive 1, so we should have the hill, and then, of course, the valley. Now I'm just going to repeat the same thing, but clearly I'm out of room to go up to 12 pi on the right, so I'm going to subtract. And I just try to use as much room as I have, try to make it look accurate. Again, no judgment. Maybe a little judgment. Judge my own. Okay, so same thing. I want to draw that hill and then the valley. So there's the hill, valley. Kind of got away from me, but you get the idea. So again, try to, if you have a horizontal stretch, try to widen it more so from your standard sine curve. Do the best you can. All right, one last one, and then I'll quit tormenting you. So amplitude, absolute value of A, period, 2 pi over B. Our B is a quarter. So 2 divided by a quarter, 8. Now, I can't say this is going to look a whole lot wider than the last graph to try to fit it to 8 pi, but I'm going to do the very best I can. Increments, period, divided by 4. So this graph should be really wide, especially compared to our first graphs that we were doing by half pi. Again, no promises. We're going to use the space we have. So I'm drawing the widest x-axis I can possibly fit. Okay, so amplitude 1, so our height's not really changed, but we're scaling by 2 pi. Now, does that look wider than my last graph? I can't promise you that, but let's label it accordingly. Scaling by 2 pi. 2 pi plus 2 pi plus another 2 pi plus another 2 pi. All right, cosine. Cosine starts at the amplitude, starts at A. -1 is our A on our lead coefficient there. So we're starting down here at -1. Center line, up 1, center line. So cosine, we just have one big hill. And of course I'm going to go to the left because I can't fit out to 16 pi to the right. So I'm just trying to make it as wide as I can, subtracting 2 pi this time. So I'm doing my best to draw them accurate, but it is difficult when you have limited space. And I'm just going to repeat this same curve. Got it. So try to scale them if you can as close as possible, but I know it is difficult. All right, next lesson we will be doing the shifting up, down, left, right. Have a great day.